Hello, welcome back to my channel. Today let's try another Leetcode problem, number 55, jump game. So you are given an integer array nums. You are initially positioned at the first index of the array, and each element in the array represents your maximum jump length at that position. So this means at position index 0, you can jump 2 steps. It means you can jump to this index 2. Yeah, so for this example, we can jump 1 step from index 0, we go to this index 1, and here this number is 3. It means from this position we can jump 3 steps, so 1, 2, and 3. You go to the end of the array. Yeah, so if you can go to the end of the array, it will return true. If you can never go to the end of the array, you will return false. Now let me go to the whiteboard to explain what it looks like. After that, I will go to the code editor to finish my coding. Now, you can see that basically we have example 1 and example 2. I'm going to use the DP method to explain it. So first of all, we can stand at the first position, it is index 0. So at index 0, it is always true because we can stand there. Yeah. And here we have the first number. This number is 2. It means from index 0, we can jump 2 steps. So from here, we can jump 1 and 2. Yeah, if we can jump 2 steps, but that is always true. But what if we cannot jump? We need to find a condition. Yeah, so if the number, this is 2, it means we can jump 2 steps. Yeah, it is okay. So what about we goes to here, goes to index 1, it means we can jump 3 steps. Yeah, so it means also we can jump to this position. Yeah, what about we goes to index 2, it means we can jump 1 step. Yeah, we can jump to this index 3. And when we goes to index 3, we can also jump 1 step at index 4, and then we can return true. But what is the false condition? So we only need to check the false condition. If we find the false condition, we're gonna return a false. Otherwise, we're gonna return true. So what is the false condition? It is something like this is 0. Yeah. So it means if we cannot exceed to this position. Yeah, for example, if from here we jump 1 step, and then from here we cannot jump anymore, we will return false. But how would we find this position? We're gonna use some tricks. We're gonna define a furthest variable. So this furthest is f. So this furthest variable is the maximum jump. Yeah, we can jump at each of the index I position. So for example, at the first position, it is 3. We're gonna return. We're gonna have a true. This t is true. Yeah, so it means from this position, the furthest is 4 steps. We can jump 4 steps. But we need to check at which position we cannot jump. And this position should not be at the last position, at the end of the array. If this position is not at the end of the array, and also at this position we cannot jump anymore, we will return false. Otherwise, if we didn't find such a position, we're gonna return true. But how would we find such a position? So this position actually, it is the furthest. So it is the furthest position. So furthest position is at each point, what we can jump to the furthest. Yeah. So if the furthest position is less than and equal to I, so here it can never be less than I because even it is a 0 because it is always be positive integer. Yeah. So for the furthest position, if it is equal to the index I, and this index I is not the last index, we're going to return a false. For example, here, from this position, this number 0 plus 3, the furthest is 3. 3 is more than the furthest. 3 is more than index I, more than index I 0. It means we can always jump. Yeah, And when we go to here, the first index 1 position. So the furthest is 1 plus 2. It is also 3. Yeah, it is more than I equals to 1. It means we can jump. And then we go to here. This one. It is index 2 plus jump 1. It means it is 3. The furthest is 3. 3 is more than 2. It means we can jump. Yeah. If it is more than the index, it means we can jump at this position. But when it goes to here, so here the furthest is still 3. Yeah, because this is like 0 plus index 3, and our furthest is still 3. So the furthest is 3, the index is 3. So it means the furthest equals to the index I. It means at this position we cannot jump anymore, and this is also not the last position because the last position is number 4. Yeah, so we're gonna return a false. Otherwise, for this loop, we didn't find such condition. We should always return a true. So this is the DP method. So this is why we goes to index 3. It is a 0, and this furthest is still 3. 3 equals to the index 0. It means we stuck at this position and we cannot jump anymore. So we're gonna return a false. Now let me go to the code editor to finish the coding. Actually, the code should be much easier. Now let me define a variable. It is called furthest. So the furthest should be equal to 0. And I'm also going to define a n. N should equal to the length of the nums. Now I'm going to check for I in range n. I'm going to check the furthest. So what is the furthest? The furthest is the max of furthest and nums I plus I. Yeah, so this is the definition of the jump. So at the position I should use the nums I 3 plus this 1. So this is the furthest position I can jump. Yeah, so if furthest is less than or equal to, here I can also use equal to because less than is not necessary. If the furthest is equal to the index I, because the index I is the position, and also this index is not the last position. So what is the last position? It is n minus 1. I'm gonna return a false. If I didn't find a false inside of this loop, I'm gonna return a true. So the time complexity is still O(n). Now let me run it to check if it works. Yeah, as you can see, it works and it's pretty fast. So that's basically the entire code. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like that. Bye.